Hi, today we're going to be talking about solving for a missing side using the Pythagorean theorem. So, an important thing to remember is that the Pythagorean theorem only works if we have a right angle triangle. So, if this triangle did not have this right angle right here, 90 degrees, we wouldn't be able to use this method. In fact, we'd have to use another method. But in this case, because this triangle has a right angle right here, we can use the Pythagorean theorem to solve for x. So let me just write down the Pythagorean theorem right here. So that's a squared plus b squared equals c squared, right? And we want to remember that c squared, this c, is equal to the hypotenuse. And remember that the hypotenuse is the longest side. So in this case, it'll be this line right here, x. So this is the hypotenuse. X is going to be the hypotenuse. So we're going to be solving for this side. So to solve using the Pythagorean theorem, all we got to do is plug in the sides that we have into the equation, right? So let's do that right here. So, and it doesn't matter which one goes with which. It doesn't matter if 3 goes to A or 3 is B. For the sides, it doesn't matter. Only the hypotenuse. Only that the longest side is equal to c squared. Okay, so let's do 3 squared plus 4 squared is equal to c squared. And we don't know what c squared is, right? We just know that it's x. So we're just going to write x squared. So now that we have our numbers here, let's solve it. So what's 3 squared? 3 squared is equal to, well, 3 times 3 is 9. 4 times 4, right? 4 squared. 4 times 4 is 16. Sorry, 16. And x squared, we don't know what x squared is, so we'll just write x squared. Great. So now let's just add up these two numbers together since we know what that is. So let's do 9 plus 16 is equal to 25 equals x squared. So now that we have our number, we only have one number here, 25 is equal to x squared. In order to undo this, in order to get rid of this exponent, right, and get rid of this 2 right here, all we have to do is square root. Find a square root. So if we find the square root of x, that'll eliminate the 2, and we'll just be left with x. And then we have to square root 25. So luckily, in this case, the square root of 25 is actually 5. Right? Because if we're taking the square root of a number, we're saying what number times itself equals the number right below the square root. So in this case, 5. 5 times 5 equals 25. So that means 5 is our answer. 5 is the square root of 25, and 5 equals x. So this tells us that our hypotenuse over here is equal to 5. Now let's do another example. Okay, so here we have our second example, right? So we have a right triangle right here, right? We have a right triangle because it has a 90-degree angle right here in this corner. And we have two sides. We have 12 and 5. And the hypotenuse, right, the longest side here is x. And we want to find out what x is. So let me just write the Pythagorean theorem in the corner, just so we can remind ourselves. Right? A squared plus b squared equals c squared. C squared, e being the longest side. This c stands for this hypotenuse right here, the longest side. So we can plug in 12 and 5 into the Pythagorean theorem. So let's see. So let's do 12, right? 12 squared plus 5 squared equals c squared. And c is x because we don't know what it is. C squared. Okay, so 12 times 12, so let's solve it, right? So 12 to the second power, 12 times 12 is 144, and you can double check that with the calculator. And 5 squared, so 5 times 5 is 25. And we don't know what x squared is, so we'll just rewrite x squared. Great, so now all we gotta do is add up these two numbers that we have here. So 144 plus 25 is 169. equals x squared. And again, to get rid of this exponent, to get rid of this 2, all we got to do is find the square root, right? So what two numbers, when you multiply them together, when you multiply it by itself, gives you 169? What two numbers, when you multiply it by itself, gives you 169? And our answer would be 13. And again, you can check your work with the calculator. Remember that the square root eliminates this 2, so we can just write x down here. So if our answer equals x equals 13, we can rewrite this x as 13. So our missing side here is 13. So we have side 5, 12, and 13. Let's do one more example with a triangle where we're not finding the hypotenuse. So let's say we have triangle, let's see, 8, x, and 10, right? So here we have this triangle where we know what the hypotenuse is, right? Well, first off, we know it's a right triangle. We know that it has a right angle right here by this little box, so we know this is 90 degrees. And we know what the hypotenuse is. The hypotenuse is 10. So we want to find out what this side is, what this leg is. So let's rewrite the Pythagorean theorem again. So a squared plus b squared equals c squared, right? And so let's fill in what we know. So a squared. So let's put in that 8 because that's what we know it's there, right? We know what c is. We know the hypotenuse. We know c is the longest side, so we can put in 10, right? But we don't know what this x is, this b. So we just leave it as x squared. And again, it doesn't matter which one is a or which one is b. This 8 I could have written over here on the b side, and then the x could have been on the a side. It doesn't really matter. Again, the only thing that matters is that c is equal to the hypotenuse, which is the longest side, which is 10. So let's start doing what we know. Let's start solving what we know in this equation. So 8 squared, or 8 times 8, is equal to 64. We don't know what x squared is, so we'll just leave x squared. And 10 squared, so 10 times 10, is equal to 100. And so from here, we can just solve it like a regular equation. So let's move this 64 all the way over to this 100. So let's minus 64. So this eliminates. And let's minus 64 from this side. So when we minus 64, we get 36. So let's rewrite our equation. Let's bring down this x squared like that. Again, we want to find the square root to get rid of this exponent. So let's square root of x squared and square root of 36. Now we ask ourselves, what number, when you multiply it by itself, gives you 36? And in this case, we would get 6, because 6 times 6 gives you 36. So now we know what x is. We can plug it back in here. And now we have all the sides of our triangles. We have 8, 6, and 10. So in a case where we do know what the longest side is and we don't know what one of these legs are, all we got to do is just fill in what we know, and then we can solve algebraically like we did over here, where we minus 64 on both sides and then find the square root of each number.